feel like we have a lot of really good topics to talk about today. Like plenty of good releases coming out. I'm just gonna put here write support for Fokko.
All right, are we ready to get started?
So I think time's good. Take it away.
Okay, sounds good. Well, thanks for coming, everyone. Good to see a lot of faces here and some new folks. Hopefully, we're going to have a good discussion about spatial stuff. I'll start off with highlights as usual, and we'll get to releases. I'm going to try and roll through this stuff pretty quickly, just to hopefully have a lot more time for the spatial discussion, which I think could take a little while. So starting us off, I think I won't actually do it in this order. I want to thank Renjie for chugging along on the Rust implementation. Added expressions as well as basic scan planning. So really great to see the Rust implementation moving along. And also thanks to Fokko for using his experience building the exact same thing in Python to have the context and do all the reviews over there. So really great to see the Rust stuff coming along that well. I know there were also other features and like docs and getting ready for a release. So the Rust implementation is going real well. Thanks everyone. The next is there's a ton of good stuff happening on the PyIceberg side. So commit support for 2 more catalogs, Hive and the SQL catalog. I may have missed one because I see like other people getting in there, and it was right before this meeting. I didn't realize there would be so much PyIceberg stuff. So that was really cool. Sung, who did the SQL catalog support, also added support for Parquet name mapping, which allows Python to go and read Parquet files that don't actually have field IDs and convert them from existing tables in Hive format. So that's really cool. And of course, the one I'm probably most excited about that unblocks our next release is we've also added write support in PyIceberg. So thanks to Fokko for getting that done. It's really great to have that write support. I think that people have been wanting write support for a really long time. So it's great to be there, and we're going to get a release out, I think, hopefully at least a candidate later this week to get that out to people. Now that is primarily very basic write support that currently does a normal fast append. So it doesn't yet compact metadata files. But you can also have it replace a table entirely. So we think that those are probably the 2 main use cases that people in the Python world have. Appending new files to a table that is probably maintained by some core team that's also maintaining metadata. So as services, other services that are probably Java based go and say compact those data files, or maintain the data, or just maintain the metadata directly, that metadata compaction will happen. So I think that that's actually really good. There was also a ton of stuff. This was a double week, or sorry, a double 3-week period because we didn't have the sync in early January. So there's a ton of good stuff on the Java and JVM side as well. So we got in initial support for Kafka Connect. Huge thanks to Bryan there because he had to basically replace what he was doing in the Kafka Connect stuff with Iceberg schemas instead of Avro schemas, and that required actually doing some things differently in the Avro schema side. So that was really good. Thanks, Bryan. We added Spark support for controlling your delete file granularity. So previously what happened was you could write delete files and each task would write a delete file per partition. Now each task will write a delete file per data file if you choose to. So there's a new setting that you can set at the table level to choose whether you want file level or partition level delete file granularity. Excuse me. That's actually really important for performance on the Spark side. So Anton's other work for basically delete file performance can take advantage of file level granularity and do planning a lot faster. I think it was in seconds rather than in minutes. And then I believe that we also get the delete file cache in, Anton?
Yes.
That's another thing to highlight that I didn't actually see in the commit list, but now we are caching delete files on executors, and we're working on making that locality aware so that we can actually try and get tasks that have the same delete files on the same nodes. So delete file and application in Spark is really coming along. Huge thanks to Anton for leading that work. Also want to thank Ajantha for removing support for Spark 3.2. Always great to delete large sections of code that we no longer need. Manu parallelized file footer reads and add files so that it's not just single threaded or on the driver. We're actually doing a great job of parallelizing that, which makes it a lot easier to move files into Iceberg tables. And then the two larger issues that I had this week were the Parquet and Avro encryption support. So encryption and table level encryption continues to move along, which is great to see. And finally, I missed docs. I'll come back to that. Finally, Eduard added support in Spark for reading, dropping, and renaming views. And we're closing in on committing the PR for creating views. That's another thing that we want to talk about under the Spark. The Java 1.5 release. Another thing to highlight, this went out on the dev list, but Bits updated the docs. So there's an ongoing effort to move the docs back from the Iceberg docs repository into the main Iceberg repository, since that's where the majority of people go to edit docs. So we are very close there. The site now looks almost like a copy of our current site, and I think is basically close enough that we should pull the trigger and probably get that in before the 1.5 release. So I'd love to discuss today, and in fact, that's why it's under releases next, the steps that we need to take to move over the docs, hopefully before we get the 1.5 out, or maybe in concert with 1.5, because I think we'd all love to not go through that older docs process again, which involved updating who knows how many branches. It was actually really painful. Okay, so let's talk about that and next steps next. So we would love to get to the main site. Bryan, do you want to talk about any blockers that you know about and where people can go to look through the doc site, and make sure everything looks okay?
Yeah, so just quick overview. So now if you go to the main Iceberg repo, you'll see we still have the existing docs. These are the version docs, and then and that's the version docs that are going to the current live site. So iceberg.apache.org. I have a GitHub pages you can go to, which is I think it's just here. Yes, I'll add this link to the there we go. It's the GitHub Iceberg repo GitHub pages. So this is the new site. And basically what this is doing is trying to get this site here under the site directory have all the README docs here and everything, but I'm effectively trying to have the same thing that we had before with version docs live in that same space that we had before, and then in the under the site folder, that will be the kind of top level website, part of the portion of the docs. And as part of the release build, it will be pulling in those version docs each time and then doing a kind of master build. And this all is taken care of within a make file. I don't think we'll have time, since we want to get to the geospatial stuff today, to really talk about this, but go to the site page and there's this README that will kind of explain a lot of things. The blocker that's currently there is when we get to releasing. So on the way this basically gets set up is when you do a release, it will pull in the versions under this, basically this docs branch and this Java doc branch. And those are two just orphan branches that, if we go to them here, so you go to
Can you just, what's the blocker?
So that's what I'm gonna get to, but so if you get down to the blocker, my point is that these are two orphan branches, and I need to get some consensus from people. And so basically, each time that we build a version to doc, it goes in here, and the same for the Java docs. And that's because we don't want these version doc builds or the Java docs to crowd up our index. So every time we do a build or a release, I want to automate that to where we just basically push this code directly as part of the release step. And that's because we'll have already done reviews for the documentation up to that point. And then the Java docs is like 1,500 files of just adding the Java docs. So I don't see there being a point in the release process to having somebody manually review those. And they won't be immediately added. What will be added at the very end would be a PR that would do a final merge to main, and this would be only the release manager dealing with this stuff. But to main, there would be a PR that would essentially just update the site pages, and it will just change this version here, the version here 143, and then it would change it to 150 and automate that PR setup for you. And then you just look at the PR. You can pull an offline build, which I can talk about later, and it's also in the documentation there, and then verify that everything looks correct. So that's kind of the steps. I didn't want to take the liberty of just saying like automatic push to the docs branch and the Java doc branch. I kind of wanted to bring this to the community and discuss if that makes sense. But it really shouldn't be. I don't think. I'd rather keep this just one like automatic command run and then a PR review, and then that's all it takes to review the docs and then merge that PR.
It doesn't sound like any of this is blocking our moving over today, because we've got 140 through 143.
Right.
And we can iterate on releasing docs as part of the release process.
Yeah.
So is there anything that actually blocks us from moving over to the site today besides building consensus around, yes, we want to do this?
Yeah, basically just building consensus around that part, and then assuming that the release is all manual at this point.
I think we're okay with a manual release process because it's manual
not
today.
changing. Yeah. And
this is still much easier than it was. So okay. Do we have? Does anyone? What validation do we think we need to do in order to get onto this? Because I think this is much easier for us all to to maintain.
And it's currently building.
Bryan, are you asking for like? I mean,
I'm
at this point. Like,
yeah. Should we just have a quick vote thread and just get 3+1, so there's just like no.
It sounds like it. I just wanted
That's all we need. Yeah.
if there were any objections here.
Yeah. I just wanted to explain it so that people can kind of know where to go and look and validate and kind of have an understanding of how to do that. So if you want to take like a little bit of the today and kind of look through it, make sure it runs, you can build an offline build and validate it and stuff, and give you warm fuzzy, like do that and then give me a +1. And then we'll go ahead and switch this over. There's technically nothing blocking us.
JB? You're muted. I don't know if you're talking.
I do. Can you hear me?
Yeah.
Okay, sorry. It's probably some lag. So yeah, I say I would just propose a quick vote of a main list, and then just moving forward. I think it looks good to me. It looks pretty easier than before. The only thing that you have to double check, Bryan, is if it dates to the ISF website, just to be sure that all is clean and okay.
Yeah.
Yeah. I saw.
So yeah, I would say just a vote is okay.
Yeah, we'll prepare a PR that moves over the ASF website and or publishes to the ASF branch and moves the site over.
Should
right.
I just do that as kind of like a candidate and have everybody look at that as well, and then just get a +1 on those?
What we want to do, like, we can take care of the details.
Okay.
We'll just, yeah, we want to make sure that everyone's okay with like actually moving over. So
Perfect.
all right, cool. Thank you for getting that done. It's great to have the new site so close to release. So thanks a lot, Bits. On Java 1.5, I think we wanted to just get a handle on, does anyone need things in the 1.5 release? So thanks to JB for adding this discussion point on view support. There's a PR that's pretty close for basic Kafka Connect. So we could do that, and I'll probably try to get that in. I also think that create view will probably be able to go in. I don't know exactly when we are planning on doing a 1.5, but I think we were hoping to have a release candidate either last week or this week. There is one blocker, which is default values are being added in copy on write merge if we are carrying forward rows that have nulls in them. We're working through debugging that and figuring out what's going on. It does not affect Spark 3.5, which is definitely good news. Yeah, Jacob.
Hey, we are probably not going to make this RC or 1.5 release with nanosecond timestamps. So I just wonder what would you push nanosecond timestamps into another 1.5.1 or 2, or would you rather push that out to 1.6?
I think it depends on how we're introducing nanosecond timestamps. So I haven't thought about this in a little while, I'm sorry. But okay. Nanosecond timestamps are part of the v3 spec. So yeah, okay. Because they're essentially a new type that is not required for the v2 spec. It's basically an opt-in, right? You would need to, we need to think through, like, how do I opt in a table to say, I know things may not be compatible with this data type. And it might really cause things to blow up. So I don't know if we want that to actually require v3 tables, or if you want to be able to opt into v3 tables, or sorry, v3 types in v2. That's probably a larger discussion to think through. Do you want to maybe bring that up or propose something on the list?
Yeah. Thanks.
And I do agree with Anton. This probably belongs in a 1.6. We just need to figure out how we want to handle the compatibility and yeah, forward compatibility especially.
Yeah, I just wanted to point out that we don't have to wait like another 3 months for 1.6. If there is like community interest and sufficient features that are valuable, we can do it like as long as there's someone who's willing to be the release manager. We can do it as soon as there is enough ground for that to happen.
Yeah,
Awesome. Thanks, guys.
Okay, so I think the first two we're going to get in. We'll definitely fix the default value bug in Spark 3.4. Then the only other thing is view support, and this is one where so we've added view support for Nessie and the REST catalog. I'm very skeptical that Hive is going to make it in, just because it seems like there's quite a bit of work to do to validate that. Hive is very complicated, and the first draft of that I know broke Iceberg tables. So I would probably my opinion is we should probably not gate the release on Hive, and fast follow with a 1.6 if we end up getting that in and it's a popular thing that people want. JDBC I could see going either way. I think the main issue with the JDBC support is that it broke, or sorry, not broke. It used a separate table, which means that we don't actually have atomicity between tables and views. So I think what we need to do is probably get on the same page and make sure we're using a single table to track both tables and views in the JDBC implementation. And I don't know how long that would take. JB, thank you.
Yeah, it's done actually, Ryan. I
Oh,
did it with PR today, and I added a column on the Iceberg tables on JDBC, and both view and tables are now part of the same table. And so actually it simplifies a lot the PR. And now we have atomicity between when creating a viewer table using the same name as another viewer table. So yeah, it's not.
Yeah.
Ready
okay,
for review at least.
Cool. Dan, did you want to add anything?
Yeah, I just wanted to add that we were probably missing some test cases in the view table overlap that we probably want to add to the view, just to ensure that, like, as people are potentially building catalogs, they aren't missing exactly what we missed there, which is namespace overlap between tables and views. We should be able to handle and know what kind of errors we get when there are collisions between those things, and it should be pretty well defined from the catalog tests.
So I think that we do have tests there. Eduard, I thought, added them. We can definitely add more tests if we think there are some missing, but this was specifically around the atomicity of the operation, because you would have to basically run a SQL check to say, does a view exist, and then create the table, rather than having an atomic, like, create table if not, insert if there isn't an existing row.
Okay, so the issue is not that we didn't have tests checking name collisions. It was because it was an atomic or was not an atomic operation. It just didn't actually exercise that particular issue.
Yeah, exactly. If we're using two separate tables and have to, run multiple queries, then it's never going to be an atomic operation without a database transaction. And a database transaction is something we want to avoid, because we want this to not require, like, client or connector specific SQL.
Yeah.
And then about the test, I think that I agree with you. There are some missing tests, but what I saw during the JDBC view support is more on the table part of it more than the view. So even for the table operation, we will need additional tests related to the view. For instance, we didn't check the namespace when creating a table. If the namespace is already taken by on the same namespace with a view, so we should improve a little the test for table also. So I will create the issue with that.
Yeah, please do. I think that, building out that set of tests is definitely a good use of time.
There is one other thing that we should at least consider for the JDBC catalog, which is what the database migration path looks like, and whether that's an explicit operation or just implicit. This is a long-standing problem that Hive has, where, like, if we just made this auto upgrade your database, like somebody just testing 1.5 against your JDBC catalog will automatically promote it to using tables that use views. And if anything else is, relying on it, it just upgrades it behind the scenes.
Yeah, it was the reason why I created a table, an SQL table dedicated to view, because it simplified the update. It didn't touch the existing tables. Now as we change the SQL table for tables and view, then we have to migrate to the new schema. That's true.
Yeah.
Yeah.
So I think the question is, do we want to gate the auto creation or the auto migration of those tables, or do you want it to just happen automatically when something connects to it, which I think is the current behavior, right?
I would probably vote for auto, auto update, because it's add column the default value.
Yes, I get that. The challenge is, of course, we've got lots of different implementations that have their own SQL. Like Trino has its own implementation of how it works with the JDBC catalog. It doesn't use the Iceberg Java one. The Python one has its own implementation. We need to validate that all of those work correctly to just assume that, hey, yeah, we can go and auto update this when it touches.
I think that it would still work, right? Because even if you don't know about that column, when you insert into the row, it's going to insert the default value.
I would hope so. But like, I don't know what kind of tools or what kind of like auto mapping, or hey, is it doing like a select star and like mapping it into an object in some of those implementations? I don't know. And that's just the thing, is like, I really don't like the idea that somebody could be running a JDBC catalog in their production environment, and then just touching it with the newer version of Iceberg changes it on them.
That's fair. Okay. Yeah, I think we'll want to at least validate the Trino implementation and the PyIceberg implementation then. Yeah. Okay. Anything else that is blocking on the 1.5? We're already halfway through.
A few issues for 1.5 which are added in the Hailstone, but the peers are not at much. I think we can review them offline and see whether it is really a good platform.
Great. And Ajantha, you volunteered to be release manager, right?
Yeah.
Awesome. Thank you for that. So yeah, I guess we'll coordinate over the dev list to get everything in line, and yeah, hopefully have a release candidate very soon. And with that, let's skip the Python 0.6 discussion, because I think that it's all rolling now that we have write support in, and move on to spatial extensions. So I think we have people that have been working on GeoParquet and GeoArrow here. There's a lot of interest in adding geotypes to Iceberg, and also figuring out what it means to have geotypes in Iceberg. Things like, how do we partition by those types? Break down data so that we can automatically basically take geo queries and retrieve some of those objects. So I'll pass it over to Javier. Do you want to take it, or someone else?
I have a little presentation here, and we can take it from here. So let me actually share my. Here it is. I think it's this one. You guys see my screen? Yeah. Great. Well, so hi everybody. So thank you, Bryan, for introducing. It is a pleasure to be here. My name is Javier de la Torre, and I'm the founder of Carto. So we work a lot on geospatial, and I'm here to actually. We have three things we're going to cover ideally and fast, so that to give time for discussion. So wanted to tell you guys around GeoParquet, an initiative, a community initiative very similar in ways to Iceberg. So there's a group of people that are trying to push like for better geospatial support on Parquet, and I want to tell you a little bit about that. And we've there's been some connections with Iceberg. We want to, as Ryan is saying, like formalize this and see if we can, like push together on this. We also think that, like an important part of that is how we encode geospatial data on a field. And Joris Joris will be telling you about an open source project, also another initiative called GeoArrow, beyond what we are using now, another codings and so on. And finally, GIA has done some work of bringing Geo support to Iceberg on one implementation that they've done themselves. It's not a standard, but we think it could also be helpful for you guys to see how we are thinking. So so with that, I'm going to straight. I'm just going to go very fast on the first slides, just to go to really the meat. So obviously, a lot of products support Parquet. This is actually a slides that we used to make the case of why we needed Geo Parquet. A lot of the products that support Parquet, obviously, they do support also some sort of geospatial support as a data type, and the spatial functions is becoming more and more general in a lot of products out there. Now, the problem that we find is that a lot of those kind of implementations are very similar but slightly different, and there's no interoperability between them. So if you export, like a data set from BigQuery that has geospatial data and try to import it into Snowflake, that data type will not be respected. So it means that you have to do all these transformations and so on. So that was one of the first problems we wanted really to avoid. It's like, how can we provide now that they're adding geospatial support, some sort of recommendation about the way to add Geo on Parquet. So yeah, other things obviously I'm not going to tell you because you guys know very well. Geo Parquet is very interesting for Geo because Geo has a lot of very specific data formats that have created for many years. I think this is a great opportunity for us to converge more with the overall analytics space, and there's a lot of benefits from just using that. Going back again, this was a community-driven initiative, so it's made up of many different companies working on Geo, and we've came up together with the vision of we got to improve the Geo support on this place. But we're also doing it under the umbrella of a standardization organization called OGC, Open Geospatial Consortium. That is the one that standardize things like well-known binary, well-known text. In case you're familiar with this, it's kind of like an organization that standardizes a lot of stuff around you, and happen to have manage the working group. So the idea is that ideally GeoParquet will become an official standard, and many companies that actually follow that will have to follow on that. Now, GeoParquet, if you go to geoparquet.org, there's a lot of information to see, on our GitHub and so on, similar to what you guys do. We announced 1.0 back in September, so it is already, and there's a ton of already implementations of it. So, so pretty excited about it. Yeah, our initial goal was really, like I said, be able to export from one system, re-import in another system, and maintain the geodata type. But obviously, the other idea is vision. It goes more towards Iceberg. Is what if you actually have GeoParquet as the geo data lake in a way, and then multiple products can connect and live, live directly into those formats. What is really GeoParquet is not much. It really is just a piece of metadata. It's an agreement between the community to include a new piece of metadata that indicates how geospatial data is encoded in a binary data type. So if you're a little bit familiar with this, think about the most basic format will be you have a Parquet file with a binary column, and it has a well-known binary on it, and then we add a metadata piece from JSON on Parquet that indicates what is inside that binary column. And that is important because on the Geo, there's a lot of stuff that you might not be familiar, but there's many different projections that you can have your data. There's orientations about how you do these things. It's all these little things that are very specific to Geo, but without this, it's there's no interoperability between products if you don't know about these things. So so it's just this metadata that we add, and what we're asking is for implementations to and for reference implementation to essentially be able to read this metadata, interpret that there's Geo and know how to do it, and ideally be able to consume it, and when they output GeoParquet can also do it that way. That was the initial of it. As I said, that this is not updated. There's a lot more. There's a lot of momentum now. There's a lot of libraries already and products that have added GeoParquet support, including the major geospatial product like obviously Carto, but but also Esri and some of the major players on the field are already working on that. And we're working with the data warehouses like BigQuery, Snowflake, Databricks, and so that they work on that too. A lot of tooling. I'm gonna go through that, and yeah, this is going just to the meat. Again, I know I'm going very fast, trying to leave time for comments. So things left out on purpose. Like I said, like right now on 1.00, we've proposed encoding of geo in well-known binary. And this encoding prevents like a lot of the benefits from Parquet and like a distributed Parallelized system, but it is the most common format across a lot of the products that we wanted to call like enable interoperability. So for us was called like the way. If we talk about like a more efficient ways of like encoding geospatial data, that's where GeoArrow and Joris will talk later. That's our vision of like a more like native way to Parquet like encoding. So that will come in a later stage. We also don't have right now a way to call like enforce it, but we are putting like a paper around recommendations for performance. So in particular around it is in most geospatial like cases you need to actually push down bounding box queries. Or if not, you're going to grab too much data when you're using it. So that's a pretty important one. And the way that we're like recommending it, we just came out of a discussion around it that we tried in multiple products, is to have a field where essentially where we encode the bounding box of each of the geospatial, each of the rows in a way that makes the Parquet, the GeoParquet file, and then that way you can then push down to do like this typical bounding box query. We think that most of the use cases we want like actually should be declared in an explicit way on Iceberg, and there's been some discussions around that, but yeah, we said we were going to be looking at it after 1.0. So what we're looking at now doing, and this is kind of like a little bit of an initial kind of going here, to say we've been talking with some of you guys. I mean, like there's a group of people interested in geo in a similar way that you guys with Iceberg. So we kind of like the idea in here was like, does it make sense to kind of like try to collaborate to push towards like geo support on Iceberg 3.0? Ryan was the one that kind of say that. Not, I don't feel like I can say that, but like, could we consider like supporting geo data types, like and spatial functions in the futures? I mean, that would be incredible news for our industry and our community. And also the other thing is that like we do actually have some funding available, and we've reserved some explicit for the research of like Iceberg and GeoParquet together. There's some funding for reference implementations, data sets, and so on for GeoParquet. But there's also now we've reserved a little bit, like of money, just specific, towards Parallelized, see how we could maybe, like put these two communities together and ideally influence you guys to get to 3.0, put, like the work to make Geo a native part of future Iceberg release. So that's what I have. This was just a very, very quick intro onto GeoParquet. And we can do questions now. We can, do all the presentations and then talk after. What do you think, Ryan?
So yeah, I mean, it seems to me that the biggest blocker is you guys understanding Iceberg and us understanding Geo.
Yeah.
Because I think we all understand, like, we need to have new data types, probably. And we also need to have ways for those data types to be very extensible or very flexible, right? Because, Geo, those are very complex objects. At the same time, we need some way of interacting with any of them. So, like, if you have some shape, we need to be able to store that shape efficiently, in the library and say, like, how are we taking this shape and satisfying those bounding box queries? How do we both partition? So how do we determine where to store that shape? And then how do we run predicates? What do those predicates look like to find the shapes? So a lot of this, you know, I zeroed in on your slide on GeoParquet, where it's like, okay, we've defined what we can store in different Parquet column types, but the work of actually breaking down those shapes or you know, geometries or whatever you want to call them, those objects, and being able to run predicate pushdown is still TBD. And that is, to me, the really interesting part. Because
So I think that's a great intro, Ryan, then to actually, why don't we, Joris, tell us about GeoArrow? Because a lot of these things actually, I think, will come in that way. Joris, you over there?
Yep.
Yeah, you want to take over?
Yes. So quickly share my screen as well. Are you seeing my screen or it's busy? Okay. So yeah, one thing, Ryan, you mentioned that Iceberg will probably need new data types. Probably you want a new data type, but that doesn't necessarily mean a new like physical, like a physical data type, or in the concept that like you can already do a lot with the existing data types, as far as I'm aware and familiar with them in Iceberg. But so we did something very similar in exercise in Arrow. Is the question of you have geometries, you have a column geometries, like how do we store them? The conservative way, or the easy way, and the most widely supported way, is you serialize your geometry as well-known binary. So you just have a block of bytes, and you can store it in a Parquet file using a variable length binary column. Almost everyone supports that, and so it's the most interoperable way. It's not the most efficient way, certainly not to work on that data once you read it and loaded it into memory. And so in the Arrow project, there are already a lot of existing data types, and so we can actually use those existing data types to have a better way to store Arrow geometries in Arrow data. And I think whatever I say here for Arrow can maps to Parquet files or maps to Iceberg concepts as well, I assume. So essentially, GeoJSON is another format that is often used to represent geometries, and if you zoom in on a single, in this case, polygon in a GeoJSON text representation, you essentially get a list of the out of rings. In this case, the outer ring and interior holes, and each of those rings consists of a list of coordinate tuples. That's your coordinate sequence, like but a single polygon essentially, and then each tuple is an x and y coordinates. So you can describe this as a nested list. It's a list of a list of two elements, and that's something that maps to existing types in Arrow. We have a list type. Iceberg has a list type as well, and so the physical representation essentially is that we just store all those coordinates in a single array, and then we have offsets for keeping track where a new list or sublist starts. That's the representation for Arrow. That's less important here because Parquet has its own, also supports a list type, but has its own way to represent that in the file.
So is there a problem that the GeoParquet supports well-known binary, but Arrow is using the list of lists approach?
No, so the Arrow can also support well-known binary. It's more that we want to take it a step further and also allow you to use something for certain use cases better as well-known binary. And so that's the reason that we are defining, okay, which data type can be used in Arrow if you want to have faster access to your raw coordinates, and then these nested lists. And so for a multi-polygon, you get a list of either a fixed size list or a struct for X and Y if you want to have X and Y separate. That's for how we can store it in Arrow. That also maps directly to Parquet file. So that makes that we have the option for Parquet to either choose, okay, I want to store it in well-known binary in like a variable size binary column, or I can also in Parquet store it in such a nested list with the struct column.
So you convert when you go to file storage.
Yeah, and that's it will be most often a choice, a user choice, whether they want to store it as well-known binary or using this format.
Yeah. So Ryan, so also for comment, so on GeoParquet on the metadata, there's like a field to specify the encoding. And right now in 1.00, the only one that is supported, or the only one that we recommended was well-known binary, with the idea of like in 1.1 and later versions to include GeoArrow when it goes out of beta. And we think, like it stays like that. With that being said, like the majority of products right now understand well-known binary. They will not understand this type of encoding, and so it will probably take some time for them to do it. And the goal of 1.0 was really first to call out, let's ensure that there's interoperability beyond, and then moving there. Now, if we do something on Iceberg, I don't think it makes too much sense to go well-known binary way. I think probably only makes sense to go the something like this.
Okay, that sounds good, because my concern here would be like having two different ones. How do you choose, right? Like Iceberg would probably, rather than saying there's a separate data column that tells you what the encoding of the other column should be, like that sort of breaks that abstraction layer. So we would want to choose one, and I would probably go with this GeoArrow approach.
Yeah. Maybe one more comment on the benefit of using this in Parquet is that, yeah, because we, at least for the second one, so for Parquet, it's recommended to use the structured version because it's more efficient to store your X and Y separate. In Parquet, it stores better, and also it ensures that you can make use of the Parquet statistics. I don't know how relevant that is in context of Iceberg, because Iceberg keeps track of their own statistics, but at least then you have both the Iceberg statistics as also Parquet statistics that work for predicate push down on your X and Y.
That's exactly what I was thinking too. Dan, did you want to comment?
Yeah, I just had a couple questions about, like, I mean, we started with talking about how there's lots of different engines that have kind of their own flavors and representations of this. And while I get from the storage perspective, like we can do either a binary representation or, a nested structure, like what you're showing with Arrow, how interoperable is that though between like the engines? The engines might actually prefer a binary representation because they all have their own internal memory representations of how they would interpret and materialize that information, and then forcing them into like, well, you may need to change your model or do a heavier weight conversion in order to operate on these. Almost seems like it kind of puts the optimization on the storage, and the engines have to do a ton of work to get value out of it.
And this was exactly one of the reasons for 1.0 with well-known binary too. It was like, yeah, right now the easiest tools, like support from the systems is well-known binary. So if we add on, and this is a very important consideration, if we use GeoArrow on Iceberg, it will take some time for a lot of those engines to support Geo, because it's not only the support of the new data types of Iceberg, but then probably making the conversions towards their internal geospatial representation systems.
So we could potentially have a well-known binary type and a broken out type, and just have two types. If they're essentially the same thing at the end of the day, then I think we can still focus on the other problems of how do we figure out, break down storage and things like that, because we should be able to treat a well-known binary blob the same as a list of struct for a single object.
I know
Yeah,
that.
I think I really support that. So like, so in the validated implementation at Veribot to integrate Parquet into Iceberg. So the auto specification validate that and put it into manifest files. And it really takes us lots of time to make that happen. And so it will be better if like Iceberg can support some sort of more flexible data type system, right? Because in the future, you know, other people from other communities may have needs for different new data types, right?
And we don't also need to solve this now. I think right now we just need to understand what the problem areas are that we need to solve.
I just wanted to ask Joris, is there a already a existing like conversion, like set of conversion functions between the well-known binary and the geo arrow? Because that's potentially another option is we, you know, at the very beginning focus on interoperability, well-known binary, or sorry, I meant to say optimize for performance, but then have a kind of escape route initially for well-known binary and maybe even have a setting where you could store both. So.
Yeah, it depends very much on what type of system that you're using to process data further. Like the Python tools that I'm involved in myself, like QPandas, they support it. Gidon supports it as well. I think Apache Sedona supports it as well, but I'm looking at here. But there are of course many others that don't yet have any custom support, like other.
Sorry to interrupt. We only have 5 minutes left, and I think we sort of understand the data types, the two types that we're talking about. I know that there's a raster type as well in I forget the name of the one that built, but
yes.
but I think probably focusing on the shapes and these things is a good starting place. Can we move on to understanding like how do you guys store these things? How do you take one of these either well-known binary blobs, like essentially a shape, a polygon, like or a multi-polygon, like Joris was saying? How do you normally want to store those, separate them into files and things like that? Because I think that understanding that problem will help us figure out what we need to do on the Iceberg side.
Right. So that goes towards, you know, like, and we didn't probably prepare for that, but, you know, like, then there's the question around partitioning, right? If this is what you mentioned around it. So, so we working with a number of, you know, like data providers, you know, like that are publishing like large data sets using GeoParquet, and a very kind of like, and there's not like a one way of doing this. Actually, every implementation away has a very different strategy. Okay, like if you look at PostGIS and the way that it does its own storing, how you cluster with Postgres, very different probably the way that Snowflake does it, the way that BigQuery. There's no consensus on a way of doing it. That's the first thing. On a what?
Sorry, I think that's okay, because there's no consensus on storing normal table data either. What we normally do is make that configurable. So you can say, you know, here's a function to derive the storage. We call it partition, right? The partition data for this this object. And if we can have that function, and then we can also take queries and use the data from that function to satisfy the query, that's really what we like to do. So like for time data, we can break it down by hours or minutes, or sorry, hours or days, and you choose which one you want. Then you also go and, you know, we can take a time range query and bake it down into a query on the partition level. And that's what allows us to efficiently, you know, pull up data files that match a given query.
Right. And for that, I mean, like we can tell you, and we can have open discussion, for example, about like things like, for example, like space filling curves and so on. That's a very common way of, like partition, like spatial data sets, and a lot of, like implementations use that. Either S2, H3. There's multiple ways to do that. So there's different techniques around that. I mean, there's also like to a minimum. And like most people are right now partitioning for things like, you know, like by country. I mean, we don't partition normally the geometries. So we don't break up the data types themselves. So, you know, like an object normally is not divided. If that's what you mean. So the polygon, I mean, you can, yeah.
I assume that's
So in our implementation, we did solve that by adding a space filling curve to our Iceberg implementation. I do have some slides. I actually prepared some slides for presentation, but I don't know if you have enough time for that.
Yeah, we only have a couple minutes left. I think diving more into this issue would be probably a good idea. Why don't we set up some additional time? I don't know that we necessarily want this whole group, but I think if we put this on the dev list, we can say like, hey, we'll set a time, and anyone who's interested in contributing can come.
That'd be great. So let's follow up on that, Bryan. I'm happy to put it on Slack and so on, and we can then invite also more people from GeoParquet and have a specific discussion around that. That's great.
That sounds great. Thank you guys for coming. I think this was really interesting, and I'd love to hear about the basics of what we want to do, because I think there are probably a ton of ways that we can do this. I would love to start with the basics of how does it work in the general case. You know, so you can fill in different space filling curves. That's great, but how do you reduce an object to a point on that space filling curve?
Okay.
Right, like covering those basics, I think would be super helpful, and then we can figure out where to go from there.
That's great. Yeah. Well, thank you very much, guys. We'll follow up then on Slack.
Thank you guys for coming.
Thank you, guys.
All right, thanks everyone. See you next time.
Thank you. Cheers, bye.